My name is Kosmas Kepesidis, and I'm a senior scientist in the BIRD group of the physics department of the University of Munich. BIRD stands for Broadband Infrared Diagnostics, and it is an interdisciplinary group that consists of laser physicists, molecular biologists, data scientists, and clinicians. And the main topic of research is to explore the potential of detecting human disease using infrared spectroscopy of liquid biopsies, and we do this with the help of machine learning algorithms. And this entire approach is known as infrared molecular fingerprinting. Molecular fingerprint corresponds to the pattern that we detect using our infrared measurements of human blood. And the important thing about it is that it is very distinct, it is very different among different individuals. It is also stable within clinically relevant timescales. But the most important thing is that it contains a lot of information about the molecular makeup of human blood, and one could use this information in order to detect disorders or diseases such as various types of cancer. So the main benefit of minimally invasive disease detection methods is that there is no need for the patient to undergo something like a surgery, which could be potentially harmful. And it is true that there exist blood tests that have the capacity to detect diseases, but they can do it mainly at the stage where the disease itself has been already developed and the patient has already symptoms related to this particular disease. So what we are trying to do with our approach is to develop a method which could potentially capture the patterns of the particular disease at the very early stage of its progression. There exist other studies out there which follow a similar approach. But in the most of the cases, these studies suffer from limitations. One of these main limitations is that these studies typically use a very low number of samples, and they typically focus on detecting disease which has already been fully developed. So in our approach, we collect a lot of samples and work with much larger data sets. And this gives us the ability to do a little bit more detailed investigation and also collect enough statistics so that we can be sure that our approach and the conclusions that we make is fully generalizable. And gives us also the ability to analyze further and make sure that, that our medical test has been tested and its performance has been evaluated in different categories of people in terms of demographics. I concentrate mainly on the data analysis, which consists of a few steps. So first of all, I work a little bit on trying to design the study itself. And once the samples have been collected and measured by the laser physicist, my first task is really to perform the so-called pre-processing of this data in order to make the data analyzable. And once we achieve this, so we essentially proceed with the statistical evaluation of the data and also with the production of models using machine learning algorithms. So machine learning refers to a category of algorithms that have the ability to learn from data. They essentially learn patterns in the data which can be exploited for answering a particular scientific question. It has been really developed into a project, and the main topic of it is to try to find what is the best machine learning based approach for our purposes. Up to now, we have been able to collect of about 5,000 samples. And these samples come mainly from our partners at the hospital of the University of Munich, but also from the Asclepios clinic, which is also located here in Munich. So we have collected samples from people with cancer, from patients who have similar symptoms like the cancer patients, but they have rather a benign disease, and also samples from healthy volunteers. And what we have done is we have really figured out a way to produce models that can reliably detect cancer and essentially classify people among these three groups with a very good accuracy, and at the same time gain information not only about the presence of the disease or not, but also about the stage of the disease. One of the main challenges of our work is that in order to be able to get a deeper insight and analyze more detailed questions, we require to have more data than we currently have. Another challenge is that we really need to work towards the direction of identifying potential biases that exist in the data and try to find ways to neutralize these biases. But we have taken a very big step towards this direction. And in a recently published paper in the scientific journal eLife, which was published in October 2021. So we have tried essentially to provide an analysis where we close a lot of these loopholes that are related to these types of problems. Our team, which is led by Mihaela Zygman, collaborates with laser physicists from the broader group of attoworld, which is led by Professor Ferenc Krausz. And the main work of this physicist is to develop a laser-based approach for performing infrared molecular fingerprinting. And as it was shown by Joachim Pupeza and his team in a paper published in 2020 in the Nature journal, this laser-based approach is much more sensitive compared to the conventional approach. And we believe that this additional sensitivity could provide us with more informative measurements with respect to the cancer detection. So that was complex research work, and a lot of people have contributed to it. But just to mention a few key players, I would like to mention Marinus Huber, who has contributed extensively to this work, and also Mihaela Zygman, who has led the study. So up to now we have done a very first step but important step towards the development of the medical test. And we believe that within several years we'll have a fully developed medical test that can be used extensively in the medical practice.